So this paper is joined with James Mitchell and Johnny Grunge. So as you said, this is being funded by ESCoE. We are very happy for that, otherwise we wouldn't be able to do this at all. Okay, let me start. And you know, feel happy to ask me questions during the talk, because otherwise I probably get bored with my own words. So the paper is about communicating data uncertainty, right? So the first thing is try to motivate what I mean about data uncertainty. So the idea here is that most of the economic statistics, not all of them, are subject to data revisions. And this is something that's very natural. It comes from the fact that all the statistic offices in the world...
Their microphone is closed. They are on mute.
Okay, sorry about that. I was told that this was already on, so.
Hi.
Is that better? Can you hear us? Yeah? Okay.
So we didn't test whether they could hear us before the IT guy.
Well, as you guys said. Okay.
Okay. You want to? So is.
Yeah, maybe let's start again over because
so
there's more people.
I guess people in Newport can hear me now. So before they couldn't. Okay. So let me start again. So the first idea I want you to keep in mind is the following. So this paper is about communicating data uncertainty. So the first thing to figure out is what data uncertainty is. Okay, so the idea is that most of economic statistics, and here you're going to see are going to be mainly concentrated on GDP, gross domestic product, but most of the concepts here could be applied to other statistics like unemployment, inflation, employment, productivity, for example, too. Now, the idea is that particularly real GDP growth is subject to data revisions, and what I was trying to say before, that this is a very natural thing to happen. The reason is that most the statistical offices, they have this trade-off between reliability and timeless. So they like the idea, they are pressured to release data as soon as possible, but of course the data then, the estimate of GDP release then doesn't have all the information required to have a very reliable estimate, which means that because of that, the data is usually revised. Okay. Now Munsky, which wrote, so this is actually a very academic kind of slide, talk about these issues of data uncertainty, and they call this kind of uncertainty that's due to data revisions, which is different from the uncertainty that comes from survey sampling errors, as some kind of transitory uncertainty. It's transitory because over time it tends to vanish. So over time, this is the kind of uncertainty that would disappear. Now, why would people like me, people that do academic research in economics, are actually interested in these kind of topics? Now, the reason here is the following. When we think about modeling the economy, we have economic agents in there, and the fact that the GDP data may be uncertainty means they can make, they may affect the decision making and may affect also consumer and business confidence. Let me give you some examples. So these are examples from the academic literature. So Warwick in 2003, what they actually show is that, if you have a policymaker, like someone that makes monetary policy decision that depend on GDP growth and inflation, the fact that GDP growth is subject to data revisions means that the optimal monetary policy decision could be quite different if not, just because the decisions are based on initial releases that are uncertain. Actually, in that paper, the recommendation is actually to make very smooth monetary policy changes as the new data gets in. From other point of view, so as I told you before, in the academic literature, we like to model agents. So from that point of view, for example, there are some very recent models in which business cycles in the economy are caused by waves of optimism and pessimism. And the way that happens is due to something called strategic uncertainties. And to have that means that agents in the economy have to get information. And the fact that my GDP measure may be different from somebody else's GDP measure may create this kind of strategic uncertainties. So I'm trying to say to this is that the notion that uncertainty may affect decision making is there in in the say, economic theory kind of literature. Now let me go on how a statistical office usually release GDP data. So these slides we started using by James 2 weeks ago to present this in the Bank Canada. That explains why my second example here is Statistic Canada. So these are 3 different statistical offices and how they release their GDP data, or what they say in their main headline press release. So the ONS says, for example, here, gross domestic product in volume terms was estimated to have fallen by 0.2. So the word estimate there is an interesting idea. So it means estimate. So the question we have actually in this kind of paper is figure out what people really pay attention to that estimate, if they take GDP at face value or not. Is Statistic Canada interesting? Doesn't use the word estimate at all. It just says real gross domestic product grew by 0.9%. That actually doesn't mean that the data are not revised in Canada. It just means that, I don't know, don't ask me why they did that. The Bureau of Economic Analysis in the United States does similar thing as the ONS. So in this case, actually, they're talking about real gross domestic product, annual rates, so these guys like analyze rates, 2%, blah, 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 according to the third estimate. So they do use, again, the word estimate, and actually the third estimate means it's actually a revised estimate of US GDP growth. So the main headline communication of GDP values, it might have some elements that may lead you to think that maybe we're talking about an estimate, but sometimes not. So that's basically how it is, okay? So I told you that, if we're uncertain about GDP, economic agents maybe would make different decisions. But the question is, do we really know that they are certain about GDP? It might be that when the ONS says GDP has fallen by 0.2%, people just take that number at face value and take this 0.2%, that's it. It's set in stone. Is it? No. So this is one of the questions we actually try to address in this research. Okay, do people really think it's 0.2%? Do they think that maybe that number is a bit uncertain? I don't know. We don't know. So that's exactly what we do here. So how communication of data and is uncertain authority uses in their decisions. So the way we're going to do that is we're going to try to come with different communication devices and figure out what people think about it. And some of the outcomes are related with the question I told you before. Do the people really take GDP at face value? Do they consider some uncertainty around? So why this is important? So again, I'm going to go back to the research literature here in economics. So the first reason why this is important for the literature is that Munsky wrote a bunch of papers saying that we should communicate better the uncertainty around economic statistics. He was mainly worried about the uncertainty around labor market estimates, actually like employment and unemployment, which are very contaminated by sampling survey errors. But he did a bit of work. We did a bit of work with people in Cambridge in an interdisciplinary context when we tried to think about what's the impact of people communicating uncertainty about facts. Okay, this is interesting because I come from a kind of background in which when I was trying to communicate uncertainty, I was probably trying to communicate uncertainty about forecasts, about things I don't know about the future. But the interesting context here is that we communicate uncertainty about something that already happened. It should be a fact. It's just that we have an estimate for that. Okay? So this is answer that. And the other thing too, so there is now a booming academic literature on how central banks communicate their policy decisions and how people react to it. So in this literature, they start looking at, so in the old ways, we would look at how financial markets react, how professional economists react. Now they're looking at how the public reacts to that. And in particular, this paper here by ESCoE used the kind of methodology that they use. They use a randomized experiment to figure out how different ways of communicating monetary policy change affect the way people think about future inflation. Okay, because in economics, we have this thing that one of the main reasons of monetary policy is to kind of control a bit inflation expectations. So it's linked to that kind of thing. So it's a kind of expanding literature in macroeconomics nowadays. So what we're going to do is the following. So remember, I wanted to figure out the impact the communication of uncertainty has. And the way we're going to do is we're going to use randomized control experiments that are going to be conducted online. And we're also going to use some results of expert survey, in which we talk to economists, basically. And what we're going to try to figure out is that first question I motivated before, whether really people, when they see this GDP estimate, if they perceive any uncertainty around, if you just give them a number. We also figure out what the understanding. Interesting. This is interesting. I was going to say that, yeah, okay, came back. Good. Second bullet point. So the second bullet point is the following, is that whether the way the public understands uncertainty and changes depending on the communication we do, depending on the format. The format here is going to be, we're going to use words to communicate uncertainty, and sometimes you're going to quantify the uncertainty as well. I mean, you're going to try to figure out which one is more effective depending which kind of outcome we're interested in. And finally, I think this is very interesting too. So again, this comes from linguistic literature. So once you tell that GDP is not 1%, it's 1, but there is some uncertainty around, some people may look at you and say, oh, but then you might trust the data or the person that produces the data. So we're going to look at that, whether there is any impact on what people perceive the data uncertainties are due to. Okay, so this is the questions. Okay, I'm going to describe now the experiment. Remember, you can stop me anytime. So the main experiment is this one. So as I told you, we're going to do a public survey and we're going to do an expert survey. So the one that's randomized is this public survey. So the way we did is that we have about 3,000, a bit more respondents. The number of observations here is going to be large enough for us to find some interesting results. They will carry out by Dynata. We prepare everything. And they're representative of the UK population. Now, there are 3 key elements here that I want to emphasize now. So the first thing is that what we want is to measure the causal effects of different communication tools on a set of outcomes. Okay? So there are 3 main words there. First, we want to see causal effects. That's going to be the last thing I'm going to explain why we're interested in that. The second thing is which kind of communication tools are going to be using. And finally, the outcomes. So what is in this slide here is actually the outcomes. Okay? So the outcomes are going to be some of the answers for some of the questions we did in the survey. And the questions, they have some questions that try to measure the qualitative perceptions of accuracies of the public on GDP estimates. For example, we ask what they thought, how accurate is a specific number. We ask about what they'd be surprised if the data was revised to a specific number. What they thought about data revisions in general. The other one is about some quantitative perceptions. So we're going to try to infer, if they have some quantitative measure of uncertainty in the backs of their mind somehow, or if, depending on the communication methods, that they are perceive certain changes. And finally, we're going to see whether the communication tools have impact on their understanding of the causes of revisions. Okay, so remember, we want people to think that data revisions comes from the fact that the initial releases are based on incomplete data. So they're not caused by, some random error or,
Usually.
Political, I don't know, somebody manipulated it. So we want them to understand that that's part of the business, basically, of releasing economic statistics, not something extraordinary.
And just to clarify, are you always talking here about GDP growth and not raw numbers of real GDP?
Yes.
Because you think there's going to be a difference in communicating, say, billions
We
pounds
thought,
billions.
so we spent time figuring out what's the number that would matter more. And we figured out that the number we were more interested are the ones that more big influence on decisions, right? So basically, actually, what we're going to communicate is going to be year-on-year GDP growth. The reason is that that's a smooth number, and is the one that, for example, the Bank of England uses when it communicates forecasts and talks about policy decisions. So we're not going to use the number in billions because, it's even a hard concept to think about it. So we can think about it that, if the economy is growing at 1% or 2%, it's going fast and slow, and that gives a notion of the current state of the economy, but we're not going to be using the volume levels. I think from our point of view here, we could try, but I think because we want links on data uncertainty, on a bit of decision making, on things that people care about, I think the growth rate is more important. Yeah, so that's why. So it's going to be GDP growth. Actually, that's probably in the next slide. So we're going to, so that's it. So the survey, the public survey was carried out in November 2018. So basically why we tried to use that was, there was a release on November, the 10th of November, which is the release of GDP for 2018 quarter 3. So we use that number. I know that the release there is normally quarterly growth rates. We compute the year-on-year and we use that number. It's a 1.5%, which is a nice neutral number. We have more problems if it was too low or too high, I think, because then we're going to have to repeat this, because it might depend on the conditions of the economy we're in. So this is the number. The way we communicate is the following. So first, the headline that uses the word estimate. So this is going to be very similar to the usual ONS headline. Then we're going to add a word about to see if that makes people think more that there's some uncertainty on this thing, or they're going to think different, I don't know. And then we're going to add a phrase that says, subject to revisions as update information becomes available. So it's going to be a kind of, you're going to have the headline, you're going to tell people directly that, it's the initial release and it's subject to revisions. Then we're going to have different sets of communication tools that have the same phrase as the last qualitative one, so it has all the qualitative information, plus some quantification of uncertainty. So I'm going to show you in a few slides how we quantify the uncertainty. So we quantify, and then we communicate using some figures. So one of them is a predicted interval, and actually we use words a bit to explain what the interval is, or if people that don't understand well probabilities. We use a density strip, I'm going to show this soon, and we use a fun chart. So we kind of increase the degree of information, of quantitative information communicated, okay? Now, the interesting thing here is that we're going to do a randomized experiment, which means that, after answer some questions online about some individual characteristics, the person answer is going to be randomized in 6 different groups, and each group has a different communication tool, okay? The advantage of doing that is the following. So when you design randomized control experiments, what we're trying to do, the advantage is that we're able to measure causal effects. The reason is that when we use observational data, everything is correlated with everything, and which means it's very hard to disentangle a specific effect. Now here, because I randomized the communication tool, that means that that's not going to be correlated with any kind of individual characteristics. And actually we test. I spend lots of time checking whether there was anything wrong in the randomization, and it seems to be pretty random. So the advantage of this is to remove loads of confounding effects. Okay, so you're going to see, for example, there's lots of people in the survey that probably don't understand well what GDP is, but they allocate, there's the same proportion across groups. So, which means that when we want to look at the different impacts of the communication tools, this is not correlated with that kind of characteristic. Okay, so this is very important. And again, pushing a bit further this, so we do this way because we think that if you're going to make a decision on whether to communicate uncertainty or not, I think it's better if it's done after some kind of research like this, in which she's able to assess causal effects that are beyond the usual correlation effect. Okay, so we can, I think, when I teach econometrics in the business school, so when I say that this is causal effects are the holy grail in economics, and this is one way to get it. And the reason why this is very important is that if you're going to put your hand on fire on a policy decision, it's much better if it's based on a cause effect and it's based on a correlation. Okay? So this is an important issue on our design. Okay. So in addition to the public survey, we also did expert survey. So we used the ESCoE email list to find people to answer the survey. There are many questions in both surveys that are the same, and there are many questions that are different. In the end, we got a bit more than 120 experts. There are people from the NS and the banking, there are people in academia, people in government department. You're going to see that occasionally I'm going to use some of the results from the expert survey because some of the questions are exactly the same. So I can try to compare the answers between that survey and the public survey, particularly in comparison with people in the control group here, which is the people that basically are going to get just the communication is going to be GDP estimated something, which is the same thing as the expert survey got it. Okay? We ask more questions for experts as well on their views that I'm going to comment in the end of the presentation. Okay, so you guys might be thinking, oh, how she got this measure of GDP uncertainty. So the way we did is the following. So there are two central banks in the world that actually communicate data uncertainty. One of them is the Bank of England, because the fund charts, they have bands for historical data in addition for future data. And the other central bank that does is the Riksbank, which is the central bank of Sweden. They do exactly the same thing. Both of them, the way they do is that they assume a kind of Gaussian density to kind of communicate this uncertainty. And we're going to do the same, okay? So the way we're going to do is that we're going to communicate, as I told you, the year-on-year growth rate. And then what we did is we got some standard errors for the Gaussian density. And the numbers we're going to use is going to be, remember, this is year-on-year, okay? So the average is about 2. It's going to be 0.8%. So let me explain where that number comes from. So what we did is that we look at initial releases of GDP for observations between 1993 and 2013. So this is 20 years. And then using these observations, we compare the revision, between the first release and the release published 4 years later. Okay, so we have a paper arguing why 4 years later, seems to be a reasonable estimate to use here. So basically, we incorporate, quite a lot of revisions, and we have to shorten up the observations to be able to compute that. And then in that case, the standard error or the mean square of the revision is about 0.8%. And we're going to communicate, you're going to see my intervals have basically no bias in it. So it's going to be the first release plus a minus 2 standard deviation 0.8. This actually gives a 95% interval. Here actually I have the numbers implied for the 90% interval. It's going to be between 0.2% and 2.8%. But you're going to see that we're actually going to communicate, they're going to be 60% intervals. You're really worried about this number getting near zero there. So we try to reduce a bit the confidence interval. But this is the numbers we're going to use, okay? So all the data uncertainty here is due to data revisions, and is based on the average of historical revisions over time, over a very long period. Because if you get only the last 10 years, you know, the numbers of the 2008 to 2000 recessions are much bigger. So you need a long period there. Otherwise, that number gets bigger. Okay? So let me show you how these communication tools look like. I know this is very small. Just to say that the group 1, which is the control group, is going to just get the following. This actually stays in our questions in the top. GDP is estimated to have increased by 1.5% during the last year. We use that because it's a year-on-year, and we thought it's an easy way to do it. Then group 2 gets the about. Group 3 gets the but it's likely to be revised. Group 4 gets this thing here, which is an interval, and gets an explanation of that thing that says, look, this is a 60% interval, so there is a 6 in 10 chance that GDP is going to be between 0.8 and 2.2%, and explains clearly that scores due to data revisions. Then there is that other one, density strip. Now the reason we did this, all in blue, so the colors are not different, again, comes from the literature. They say that colors would matter. And the literature does look at these different types of ways of assigning these probabilities. So we did this too. So this is the density strip. So you see, have a darker shade, a bluer and a lighter. And again, it has lots of explanation on what these things are. And finally, we do like in a Bank of England style, which is kind of doing a fun chart, but we convert to something that looks like a histogram and a bell curve, in which you have the shape like that. You have the probabilities here, but we have the probabilities written there too as well. So this has a more detailed information on the kind of uncertainty around. Okay, so this is the 6 ways basically. Words first, adding more words, and then adding more information. Okay. The fact that we use words and numbers is because, again, previous research done in different areas, not in economics, in which the words may help people understand what's going on in the plots. Okay, so how are we going to measure the effect? So remember, each group is going to have a different of these communication tools. The groups are randomized, so the software allocates people into groups. So then you're going to have many questions after that. So the communication is going to be in the top of the screen always, and then you're going to have some questions. And the way we're going to do it here, we're going to model the answers using a probit model. So it's equal to 1 if people answer some of the answers, and 0 otherwise. So we're going to model the probability of choosing some specific answer. And then we're going to measure whether the communication tools have effects by testing whether these coefficients B here are equal to 0 or not. So we use a dummy variable that's equal to 1 depending on which group you are. And we also include some control variables. Now, because this is a randomized experiment, we actually don't need to add control variables. We add here because reduces a bit standard errors. Okay? But potentially you could just check the difference of the answers across the different groups. Okay, that will give a rough estimate on the impact of the communication, the different communication tools. Okay, and the way it's written is that the numbers are always against the control group, that are the guys that only get the headline communication. Okay, I already told you that I check whether the randomization was done fine. There's some correlation with some education levels, and I always include education in all the regressions. You're going to see that in some regressions, I'm going to tell you the difference between each group in comparison to the control group, but also the difference of the expert group. Now, the way we do that is because they answer the same question. So we just merge the results of the survey, and in that case, we actually do a regression with no control variables because the control variables are different. But this helps us understand how different is the group of experts done in the separate survey of economists is from the control group that comes from the public survey. Okay, but in that case, we cannot really say that that's cause and effect, but it gives some interesting indication. Okay, let me talk about the questions then. So I'm going to show you the questions in 3 different sets. So the first set here is about some qualitative perceptions of accuracy. So question 11 was the first question after we start communicating uncertainty. Before all the other questions were individual characteristics questions. So the first question is, how accurate do you think the first estimated GDP growth of 1.5% is likely to be? And in my probability model, it's going to be the variable is equal to 1 if you answer very accurate and very accurate, and 0 if it's not accurate. I could decide this to do in a different ways, but the way we do here is pretty robust. So, for example, we try to estimate this with order probability, and results are very similar. It's just much harder for the interpretation. So that's question 11. Question 14: how surprised you'll be if the ONS correctly estimates for GDP growth to 2%. So 1 if it's not that surprised. So think that if you move GDP number from 1.5 to 2%, it's not a big deal. And 0 for the surprised people. And then question 18 is that are you surprised that estimates of GDP growth are regularly revised? And then the people that are very surprised are 1, and the people that are not that surprised is 0. Okay. So let me show you the first set of results.
Can I just ask you, on your question 2, is the individual exposed to the distribution?
It depends.
If
he's in group 6, yes.
Okay.
If he's in group 1, no. So it depends. So oops, great. So the questions are, so I have my presentation here in the laptop, it's just that the transmission is different one. So what I'm trying to say is that, let's wait for the, what happens if I do this?
So essentially, depends on which group you're allocated to in your randomized trial.
Yes. So think about it. What we're trying to do is to see the impact of, in comparison to the people that have no information on uncertainty, that the only information is the word estimate. In comparison to the people that have more, whether they would answer differently each one of these questions. Okay? So the idea is, if the combination tools have any impact whatsoever, I would find statistically significant differences. That's basically the idea. So it's whether there are treatment effects or not. Is our friend is not...
I think someone went to get him, so...
Not around? So that's the idea. More questions?
Can I ask you a question? Have you in any way controlled the content of the information that you're communicating with the people? So they may react differently if it's 1.5%, but what if the information that you were communicating to them was a recession perhaps?
So in that case, I need more money to run it again.
Yeah.
Yes. Yes, I agree with you. I think the current state of the economy might have an impact. So people might be more worried about GDP growth during recession than other periods. I think it was nice that we're in a kind of neutral period. So I would say that's the average period. But it might be that in more extreme kind of periods, people would behave in a different way.
I'm just wondering what the response rate was to the survey, because my impression of ordinary people, and in fact, perhaps the majority of economists I know, that if you asked them what the last GDP estimate was, they wouldn't know, and they probably wouldn't care much either, unless they're economists working using that.
So the way we did the survey is that, you kind of force people to answer. So when they sign into the survey, they kind of have to answer everything. It's the way it's
So you
done.
don't actually know how many people were contacted separately from the...
So
you can't
I get all the answers. I get all the So I got all so I know that the sample is representative of the UK economy because I can look at individual characteristics and see that it really looks like the UK population. So it doesn't, goes all over the place. For the expert survey, we look at those people that decide on answer, but not for the public one.
For the public, you get selection on people who are can be bothered to take an interest in this.
So there are people out there that like to answer surveys. We know from individual characteristics that they vary in terms of education, age, location. Now, because the communication tools are randomized and don't depend on individual characteristics, so they are allocated in different groups. I'm not much worried about it.
But we won't know.
I appreciate with the randomized control trial, it doesn't affect causal inference, but it does affect how you interpret the data.
Outside. Look, we check. I don't have any ideas in the end of the paper as all the individual characteristics. It looked pretty diverse. Yeah? You're back? Okay. Okay, let me tell you then why you see these numbers. So remember, all the numbers here are referred to the control group. These things here are t-statistics. So the things in bold mean have a statistically significant effect. And these numbers here are the impacts on the probabilities of answering that question with that answer. Okay? So there are marginal effects that they make. So for example, the control group, 82% of the people answer said that the accuracy of the first estimate was very accurate or very accurate. So most people think it's accurate. And then the people that saw the interval, they have a 4% smaller probability to say that that's actually very accurate. So the fact that we communicate uncertainty kind of makes people perceive the GDP estimate as less accurate. Okay, so this is the first thing. Then whether people be surprised about a revision that goes to 2%. Remember the headline is 1.5, so 2% it looks pretty big revisions to me. All the groups respond in similar ways. So 48% thought they were not going to be surprised, but then there are no difference across groups, which means that the communication tools make no effect here. Then the other question is whether you're going to be surprised that GDP is revised. Then you can see that people that got some of the communication tools, like the density strip, they are less likely to be surprised. Okay, 6% less. So only 35% would be very surprised, and there are fewer of them if they see the density strip. Actually, all these numbers are negative. Okay, it's just that some of them, only the ones in bold, are statistically different from 0, which means that these people, they respond different from the people in the control group. Okay? So the vision here is that some of the communication tools, like the density strip here, does seem to make people be, understand a bit better that there are revisions that might get in. Okay, and I'll be surprised about that. There is this bit here that I know you guys are going to be really interesting. So one of the individual characteristics we asked people actually to define what GDP was, and if they got wrong, we tell what GDP was before they start answering these questions. So we see these are individual characteristics. And then you can see that the people that didn't know what GDP was or guessed what GDP was, they're more likely to think GDP estimate is very accurate. They are less likely to be surprised about the revisions. So there are some impact there. The thing here is that these then are not going to be causal effects. Okay, this is important. And you can see I'm going to have a whole slide on this. But we ask whether people trust the LNS too, and you're going to see this is going to have impact in many of the questions. In particular in this one, so people that are more likely to trust their RLS are more likely to say that the GDP estimate is very accurate. Okay? So it's this notion of accuracy here as opposed to being uncertain about the number. Okay, so this is the ones that we actually ask quantitative question. So we ask something like, what do you think is the chance that GDP grew by exactly 1.5%? It's not a very clever question, I have to admit, because everyone that knows statistics, there's a continuous random variable. The probability of being exact number is, anyway, ignoring that, I put it 1, so there's lots of people here that got all over the place. Actually, people really like to answer 50-50, okay, which is a highly detaining answer. But anyway, so is equal 1, the people think that they're very certain about it, so they really like, the perceived uncertain GDP is very small, that's basically what we think. And there is a bunch of people that are more uncertain about GDP. So that's basically why we contrast here. Then we ask the question that we gave them the answer. Is this, what do you think is the chance that GDP grew by between 1.2% and 1.8%? Now the people in the control group are going to say like, no idea. I mean, I'm going to just give a guess. But some of the people that we give the quantitative pictures, they actually should be able to compute that, because this is actually 30%. Okay? So we're going to see whether that thing worked. Okay? If they figured out what that was. Another question we ask is whether people will be surprised if GDP was actually as high or low than. So you want people to give us a kind of interval for GDP. Okay? There are not many people that answer that one, so the guys are worried about. So this one, I think 80% of the public answer that one, and there are some people that just put some crazy numbers I have to remove, but there are a good 70% of the sample that I could use that to compute the interval, which interesting enough has a range of 1. So it's basically, it's 1.5, it's between 1 and 2. You're gonna see, so we wanted to see whether the treatments have any impact on the length of the interval. And then finally, we ask, look, do you think the statement I give to you provides you with loads of information that the estimate might be uncertain? Remember, if you get the control group, there's almost very little indication, but if you get some of the treatments, you probably should get a lot of information there. So let me show you. So this is a similar table. So again, you have each question like this. And the choices here are always the choice that's equal to 1 in my probit. So for example, here, 45% of the control group choose that, the GDP being 1.5% is a very likely kind of scenario. But you can see that people that got the interval or got the bell curve of the experts actually think that that's much lower. So for example, the probability of people that got the bell curve is 8% smaller. Okay? So you can see they understand a bit better that there is some uncertainty around GDP than the other ways of we communicate uncertainty. Okay? And you can see that the qualitative, the about doesn't make almost likely doesn't make any impact there. Okay? And the experts also, because they know more what GDP is, then it's natural that, there are fewer of them think that being exactly 1.5% is something that's very likely. Okay? Now, this is the one that has a right answer. So, the chance between 1.2% is 30%, which we use this word quite unlikely in the survey. And you can see that the number of people that get it right, it increases if you get the interval or if you get the bell curve. We're very happy with these results, okay? So what I mean is that the information we give in these quantitative tools make people get that question right in comparison to people that have not known this information. And remember, the groups are all the same. So there are people there that don't know what GDP is, don't understand well probabilities, but still we get an increased probability of getting the right answer about 4%. Okay? And it's significant. Now the experts don't get the question right, but then we didn't communicate to the experts our measure of uncertainty, so it's fine. We asked them to guess later on. I'm going to tell you what happened when we asked them. You can see, and then the interval. So in the interval, nothing significant. So I don't know, it might be that people just come with numbers there. We didn't find any impact of the communication. And this is the one that actually, can you see that all these numbers are negative and they're increasing this way? So this was a question that we ask, you know, the information we give has, you know, the communication tool, does it give you enough information? And you can see that it gives more information when we give more information.
Can I ask, were these questions asked in order, or were the questions randomized during?
No, the number of the question is normally on the top. So this is 15, 16, so this is before that.
Were they asked in that order? Or were they
No. You organize the results in a specific order here, which is not necessarily in the order the questions were asked. So if you see the question number, that's actually the order the question were asked.
But it was set.
It was set, and they couldn't move, so they have to answer each one of the questions. Yeah? So we put these restrictions, they do have to, yeah. You can see that, a comment here, for example, that the right quantitative answers is the only 10% got right. It was a very hard one. But the point here is not that. The point is that, you know, the people that saw the quantitative communication were more likely to get it right, which is the important thing. Okay, this is the last set, so this is question 17. So I show you already results of question 19. In the end of the paper, we actually have the answers for all these questions with all the details, all the summary statistics. So remember, they have this communication tool, and then you ask, why do you think ONS regularly publish revisions to GDP estimates? And then we gave these options, and I think we allowed them to pick more than one. So we have mistakes, more information becomes available, which is in the headline there. There's vested interest, manipulates production, and then we gave that answer to the government. We said that there's limitations, and other don't know. So in this case, I'm going to model two specific answers, which is the mistakes, the vested interest, we're going to put this together, and the right answer, which is that one. So what we see here is the following, is that there's 31% of the people in this sample that think it's due to some vested interest. So these people really probably are not very much connected with what GDP is. But interesting enough, our treatments have no impact. Okay, so the fact that we are communicating more certain has no impact on people thinking that, you know, the revisions come from some vested interest. Same thing with the treatments and mistakes. So none of these treatments have any impact. The only impact you see that's involved is the expert group, because the expert thinks, you know, it's very unlikely to be vested interest, but, you know, might have some mistakes, because I guess these are the guys that read, you know, some ONS communications, and I don't know. But the important thing here is the last column is the right answer. Okay, is the answer that I guess, you know, the statistical office would like to hear. People think that the interventions are due because there are additional information, we're getting a better measure of GDP. Now, people that saw the density strip and the bell curve, they're significantly more likely to answer that choice. So they're 70% and 8% more likely. Actually, the experts are much more likely too, but I guess they have a more expert view of what's going on.
Do you have a view on why interval is not significant in that? As
I don't know.
Interval density captures the same information in terms of the range of what the estimate may not be, but not the likelihood.
I don't know. It's hard. It's still positive, so it's the same sign as the other ones. but it's not significant as in the other cases. I'm not sure why interval. I mean, it's a good point. I should look at the literature and, you know, with forecasting to see if they have any views on why people find, because the interval is pretty simple, right? It just says there's a 6 in 10 chance to be between that number and that number. It seems that actually this is something we didn't know before doing this survey. We thought that the interval was a pretty good case. But if you look at most of our answers, the more complicated ones, the ones with colors like the density strip or the fun charts, they seem to perform better. It might be the shades, or you know, it might be the fact that there are probabilities elsewhere. So you remember you know, these ones, this is very simple like that. This one has shades. That one, you know, has the height to give you an additional notion what's going on. So they seem to perform better.
Just one reflection on that, and then I've got one question which is worrying me quite a bit about the methodology. The reflection is we don't publish at the moment confidence intervals for GDP, but we do for the labour market figures every month. And there, I think it's a measure of fact, out of every 12 announcements, 12 monthly announcements, only about 3 are actually significantly different from 0. That. Actually, that confidence intervals have virtually negligible impact on the public debate. In the time to say, you see experts or journalists or policymakers, I have to say.
You say they ignore the existence of the intervals.
Yeah, that's so. So I'm not surprised the same would be true if we tried to do something similar with GDP.
So we try to carry a bit your point further. So the way people think in other literatures is the following. So I'm going to give them more information. Are they caring about or not? This method, this helps them to any kind of the decision making. So in the expert survey, we actually try to give the people a bit of decision making. So they were economists, right? So we say, you know, how big has to be the revision of GDP for you to change your advice, okay? Which would be, you give a bit of a notion. So I guess for unemployment, you could maybe design a kind of survey like that to try to figure out if that really matters for decision making. And then of course, you know, goes a step further of the communication of uncertainty.
And the same would be true with GDP, I guess. I mean,
yeah, GDP in the private survey.
Say to a policymaker, look, GDP grew by 0.5%. Alternative 1, alternative 2, GDP grew between minus 0.5 and 1.5%. What difference does that make to policymaking?
So in the expert survey, what we figure out is that they have a notion that if the revisions were small enough, they wouldn't bother. But if we're bigger, and then the big was big to 0.5%, they would start changing their mind about what their you know, recommendation would be. So I guess and actually it's compatible with the kind of sizable revisions GDP has here. So it looks to me that, you know, it might affect, but again, we don't have, I mean, it was very hard for us to do a decision in the public survey.
The thing that's been worrying me a bit, it comes down to your question 17, or something that's followed from it. Why do we get revisions to the published estimates? And you say, well, the answer is actually more information becomes available. That's one of the 2 reasons why we get changes. The second one is methodological change over time. So it's not,
We should have
by the end of about 2 years, most of the information we're going to get, we've got. So revisions thereafter are predominantly due to methodological changes. And your 4-year thing is sort of somewhere goes uncomfortably between the 2.
Yes,
so
it goes between the 2.
You've got a chunk of the data, all of the data uncertainties, and a chunk of the methodological changes, but by no means all of it.
So the reason I did before is that I did some statistical testing. Again, you know, I can completely see your point in that. Is that I did some statistical testing and I figured out that it looked to me that there was still some, I know there's methodological change, but they're still adding some kind of new information on the measure of GDP. And that's the way I thought about that. So I agree with you that's not really because the data is not available, but it didn't look to me that.
But if you want to take methodological change into account as well, and, there are reasons why you might want to do that. The methods are uncertain, what's different from data uncertainty. You'd want longer than 4 years.
We stop at 4 years because we're already going quite long. I mean, there's some, but we should discuss more about that. It's something I'm still a bit unsure because most of the literature in this area are done with US data. And the people with US data, they stop after 3 years because when the annual revisions stop. So they're not methodological. But the UK is different. So I went further because I thought I needed more because I could see that what's going on there was new information. So anyone that wants a better measure of GDP would like to incorporate that, but it might be, there's a better way to do that. Good point. Okay. So from these questions, before I go to the bit of trust, maybe I should go. So I think you kind of try to understand. So the results kind of show that it doesn't seem that communicating certain affects people's view it seems that improves public's understanding of why the division happens, so we're happy about that. It doesn't seem to decrease the trust in the data. I want to talk a bit more about the trust. So you saw that in the bottom of my slides, I always have this dumb variable for trust ONS, and there were many cases there were volts there because they were significant. So one thing you look at it is whether people that trust their ONS have any different behavior in answering these questions. So remember, these are not going to be causal effects, but again, we have some. So we use this word, trust is associated with lower tendency to view GDP estimate probabilistic. So there's a bit of trade-off between trust and trying to put a confidence interval about GDP or trying to think the GDP is uncertain. So people didn't think GDP is more accurate. At the same time, then trust in ONS means that then you don't think that the data divisions are due to mistakes or vested interests. It's actually pretty big, the impact there. So there are questions here on the impact of trust. But remember, our communication of uncertainty doesn't increase the percentage of people that answer that's due to vested interests or mistakes. Just some comments. So as I told you, we did the expert survey. Some of the results you kind of seen. I explained to him already this decision making. We asked people in the survey to give us so we give the same way we ask forecasters. So we give them some base on GDP and ask them to give us some probabilities on try to measure their measure of data uncertainty. And on average, they give this interval between 1 and 2% with 66% probability. This is actually tighter than the one we actually estimate. It might be, as just said, that they're only looking at the first 2 years, which is probably going to be smaller. But it's tighter than the ones we have. And actually we asked them whether they have any views on communication tools, and actually there's some people that like the bell curve, and there are people that don't. And they complain that the media doesn't understand a thing. So this is, there's a whole session in there. So I think I'm gonna try to finish this. So we did these randomized experiments, and you saw I showed some cases in which you find that the way we communicate uncertainty does matter. Okay, so it might be that we've done all of this and find no statistically significant effect, and we did find. And this, of course, there was a previous literature on some other areas, so we were happy to contribute to that. And at the same time, I think we should use this methodology a bit more. So the idea of designing these experiments online and trying to ask people about their views to try to evaluate how we communicate with not only data, also policy. Remember I told you there's loads of people figuring out how we communicate monetary policy and expectations, and also how you communicate forecasts as well. How we, in our world we have to communicate all these probabilities with people with difficulties. Is a good idea to do that? What's the best way? How people react to the different ways we do communication. So if I happen to do something better, is this step we're discussing now? Is this notion that to have a more clear link with some decision-making scenario. But the ones we got from the expert survey is that people would change their advice on what to do if GDP was revised by 0.5%, but not if it was smaller, which means that they kind of attribute some uncertainty around GDP without changing their mind. Because, for example, it might be that, when asking it's 1.5%, but my forecast is 1.7. So would they change their mind? They say no. But if the difference is big, they would. So it gives a notion about how large the difference has to be for people to change their mind on the current state of the economy.
Well, thank you very much. Thank you.